I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least,
Hello everybody, welcome to ACE Engineering Academy and ACE Online Platform. So here the ACE Engineering Academy with ACE Online Platform providing online classes for various engineering courses. It may be GATE or it may be engineering services or it may be GENCO, TRANSCO. So whatever it may be, so the ACE Engineering Academy are providing the online classes. So as well as offline classes also we are running here. And coming to myself, Prasad Meghavarna. So here we are teaching the power systems. So here I am saying welcome to the world of power systems. Why? Because so it is the life of an electrical engineer. Power systems is the life of an electrical engineer, which means that so we have to generate, transmit and distribute the electrical energy. So coming to, so my name is Prasad Meghavarna. So I have done my MTech and I am doing my PhD in SV University Tirupati. And I am having 12 years of teaching experience. And coming to the syllabus of power systems here, this is the overall syllabus of power system. So the power system majorly consisting of 13 to 16 marks, 13 to 16 marks in GATE. The overall weightage of power system is 13 to 16 marks, in which we are having generation of electrical energy, transmission and distribution of electrical energy, power system analysis and switchgear and the protection. So coming to generation of electrical energy, so we are having very less syllabus, particularly in case of GATE. So we are seeing the economics of generation and economic load dispatch in case of the generation part. And coming to the transmission distribution, so here we are going to discuss about transmission distribution part clearly. Right, I will see that one, I will come back to that one. And coming to the power system analysis, so the major portion, the power system analysis is consisting of the load flow analysis and the fault analysis and the stability analysis. And coming to switchgear and protection, so we are having various protective devices, so overcurrent relaying and distance relays and differential relays, right? These are the things we are going to discuss in case of the switchgear and protection. Clear? And about the circuit breakers and relays, we are going to discuss in the switchgear and protection part. Now coming to transmission and distribution part, see here students, and this is the weightage of the transmission and distribution, right? So we are getting approximately 3 to 4 marks, 3 to 4 marks in every year in case of GATE, and 4 to 5 marks every year we are getting in the engineering services examination. And this is the weightage in case of the conventional exam, ESC. So those who have qualified in the objective exam, so this is the weightage for only transmission and distribution. See here, so in GATE, we are getting approximately minimum of 3 to 4 marks, 3 to 4 marks. And in engineering services, we are getting 4 to 5 marks here. Clear students? Now coming to the question, how many number of questions we are getting every year? So in 2018 we got one 1 mark question and one 2 mark question. In 2019 we got one 1 mark, one 1 mark and one 2 mark question. And in 2020 also we got one 1 mark and one 2 mark, approximately 3 marks. And whereas here, so 2 1 marks and one 1 mark, so we got 4 marks there. And coming to 2022, so we are getting 2 1 mark and 2 2 marks, approximately we got 6 marks in 2022. Clear students? That is the weightage of transmission and distribution in GATE examination. And coming to weightage and number of questions in case of the engineering services, as here, so they are asking approximately a minimum of 5 questions in case of engineering services 2018, and here we got 6 in 2019, 5 in 2020 and 4 in 2021, and we got 6 marks in 2022. That is the weightage of transmission distribution in engineering services prelims. And coming to conventional exam students, see, so approximately we are getting 30 to 40 marks, 30 to 40 marks, 35 here, 38 in 2019, 32 in 2020 and 32 and 2021 and 40 marks in 2022. Clear, students? So the transmission and distribution is playing a very, very important role. So to improve your score, and also it is somewhat easier compared to that of remaining parts of power system. So compared to load flow analysis, stability analysis, fault analysis, so the transmission distribution part is somewhat very easy, and we can study that much. So somewhat less theory part and more mathematical part will be there, and that mathematical part also it will be very, very easy in case of the transmission and distribution. Clear? And coming to the syllabus of transmission and distribution, students, this is the major portion that will cover in the GATE syllabus. See here, first of all, we'll see the basics of power transmission. In the basics of power transmission, we'll see the single phase power transmission as well as the three phase power transmission. Clear? And coming to the elements of transmission line, the second chapter. So in that second chapter, so we are going to discuss about the RLC, it is resistance, inductance and capacitance calculations of the transmission system. And coming to the third chapter, steady state performance analysis of the transmission line. In case of the steady state performance of the transmission line, so we are going to discuss about the performance indices of the transmission line, and we are going to calculate the percentage voltage regulation and percentage efficiency of the transmission line. And along with that, we are going to study major syllabus components like surge impedance, loading, classification of transmission lines, short, medium, long transmission line, and their ABCD constants also. And in the fourth chapter, so transient analysis and wave traveling. So actually, so in this chapter, we are not getting any questions for the past 10 to 15 years. So that still we are going to discuss that. We are going to discuss that a little portion in chapter 4. Some portion we will discuss. So why? Because we are going to write some local state government exams also. So we will take that one into the consideration. We are not going to completely leave that. We will take that one and we will prepare that one for local state government exams or any engineering services examination. And coming to voltage control and power factor correction, the most important chapter. So without a question in voltage control and power factor correction, we cannot expect a question paper, right? So this is the most important chapter, we can say, the most important chapter. And also steady state performance analysis also one of the most important chapter, right? And elements of transmission line, here we can say these three are the most important chapters. And underground cables, we'll see about the underground cable construction, single core cables and 3 core cables there, and overhead line insulators we'll see, and corona portion we can see, and the distribution system, right? So we'll go into the individual chapter wise important topics also, right? Now coming to the textbooks here, these are the preferred textbooks we can take. So we can take John Greger and William Stevenson. So power system analysis by John Greger and William Stevenson we can take, and power system analysis and design by Duncan Glover we can take, power system analysis and design, one of the best book we can say, and it is also one of the best book. And so the great professors of India, so they have given modern power system analysis, right? DP Kothari and I.J. Nagrath, they have given the best textbook of power system, right? So one of the best textbook we can say. And John Wheely publications, so electric power systems by John Wheely publications. So whenever they are publishing a book, we can trust that book. That is one of the best book we can say. So these are the books we can take any one book and we can prepare one. And listening class is the most important thing, and preparing notes from the class is the most important thing, right? Reading textbook is the next thing, not the basic thing. Basic thing is we have to listen the classes clearly and we have to take a very good notes from that one. So everything will be covered in the classes, previous GATE questions and all practice sessions, right? So whatever the important points we are getting, so everything will be covered in the class itself. Clear? Right. Now coming to what to practice, what we have to practice to get the maximum marks. See here students, so we can practice previous engineering services objective questions and previous PSUs. So PSUs means other than PSUs marked with GATE, so we can take the other one. So we can go for DRDO, DRDO question papers, we can go for ISRO question papers, we can go for BARC question paper, right? And along with this, we can go for any staff selection commission question paper, staff selection commission question papers also, and any RRB question papers also we can take, RRB question papers also we can take. So these are the major areas we can cover in the PSCs. And coming to previous gate questions, we have to cover both 1 mark questions and 2 mark questions. So both 1 mark and 2 marks, both 1 mark and 2 mark questions we can cover here. And previous electricity state board exams, so we can take Genco, Transco, Discoms like that, right? So we can take Genco, Transco and Discoms we can take of the different states. Clear? And along with that, previous Indian administrative question papers also we can take. Clear, students? So these are the question paper set we need, right? So in the class we are going to discuss all possible questions wherever they are having, right? So suppose if you are taking a topic of inductance calculations, so we'll take the questions from previous years, ESCs, previous PSUs, previous GATE and previous state board exams and previous Indian administrative questions. So we'll take all the questions, we'll discuss itself in the classroom. Clear? So here students, if we are having this practice set with you, then that is the best practice set we can have. Clear? So previous ESC questions, previous PSC questions, previous GATE questions and previous state board exam questions and previous Indian administrative services question papers. Clear, everybody? Now, so coming to important topics of each and every chapter we'll see here. Coming to here, the first chapter, the basics of power transmission. In the basics of power transmission, students, here, first of all, we'll see the basics of single phase power transmission and the basics of 3-phase balanced power transmission we are going to discuss. So in the transmission and distribution part, we are going to discuss about only balanced power system. So that in the basics of this chapter, we'll see basics of single phase power transmission and basics of balanced 3-phase power transmission. 3-phase balanced power transmission system we are going to see. Clear? In case of single phase basics, we are going to discuss about instantaneous voltage calculation, instantaneous current calculation and instantaneous power calculation in single phase and average power calculation in the single phase system. So these things we'll see in that one. Along with that, we are going to calculate the complex power and we'll see the importance of complex power and the complex power flow and their related equations also we are going to see in the single phase system. And the same thing we are going to see in the 3-phase system also. Instantaneous voltage calculation, instantaneous current calculation, instantaneous power calculation in case of 3-phase system. Along with that, we'll see the complex power calculation in the 3-phase system also. Clear, students? So with that, so we are able to solve the problems very easily in the basics part with the single phase power transmission and the 3-phase power transmission. And coming to the electrical design aspects, in that we'll see the insulation system design and the conductor system design. Insulation system design and the conductor system design we are going to see in that chapter. And coming to the next one, the transmission and distribution voltage levels in India. So what are the possible voltage levels in India? So from where to where? What are the high voltages? What are the extra high voltages? MEHV, modern extra high voltages, and what are the ultra high voltage levels in transmission part? And distribution, what are the primary voltage distribution and secondary distribution voltage levels we are going to see in that category. And what are the advantages of high voltage transmission also we can see. The advantage of high voltage transmission. So whenever you are transmitting the power at very high voltage, so what are the advantages we can get, right? There may be some power loss, less power losses, high efficiency, all those things we will see in that part. And in the structure of power system, we are going to see about feeders and the distributors, and we'll see what are the service mains, and what are the connections we can use for the transformers from sending end to the receiving end, which means that from generator to the load center, what are the connections we are going to see. And coming to the classification of conductors, in the classification of conductors, we will see the solid conductors and all aluminum conductors are homogeneous conductors, and composite conductors are ACSR conductors, and bundled conductors and hollow conductors. So these are the classification of conductors we can see in that complete first chapter. Clear? So this is the first chapter. So we can expect at least one mark question in this one, in this chapter. Clear? So we can expect at least one mark or 1 2 mark. One mark question or 1 2 mark, 1 2 marks question, 2 marks question. So in this one, any one it is possible. Definitely it is possible. So we can get from the basics, right? The most important part in this one is the first part. So taking a single phase basics and the 3-phase basics. And classification of conductors is also one of the most important. And coming to advantage of high voltage transmission, also one of the most important part. So in this entire chapter, these are the 3 most important concepts we can take. Clear, students? That is the chapter 1. So we can concentrate more on these topics. And coming to chapter 2, so the transmission line constants calculation. The transmission line, what are transmission line constants? The transmission line constants are the resistance and the inductance and the capacitance. So along with that we will take shunt conductance also, but these are the major parts, RLC. So RLC calculations we are going to see. So resistance calculation is less important, and the most important is the inductance calculation and the capacitance calculation. So we are discussing about, it's not the syllabus, these are the most important part. So syllabus is different. We are having more concepts to understand all those things. Clear? So in this chapter, so we have to concentrate more on the inductance calculation in the single phase system and the 3-phase system and the total part. So all parts are important, 1, 2, 3, 4, all are important only. So bundled conductors, GMR, GMD calculations, all those things we'll see. So we'll see GMR, GMD calculations for various configurations, symmetrical configuration and unsymmetrical configurations in 3-phase system and in single phase system also with multiple return conductors. How to frame bundled conductors. For bundled conductors, so how to calculate GMR and GMD. All the possible calculations we are going to discuss in the classroom itself. And inductance calculation for single phase and 3-phase system is also most important concept. And we'll see the capacitance calculation also. But the most important part you have to concentrate is the inductance calculation. And before 6 years we got a question in capacitance calculation. But we should never neglect that one, right? So we have to study that one also. Clear, students? And coming to the next one, the most important parts of the steady state performance analysis of the transmission system. So in this, so the main aim of this studying this chapter is to calculate percentage efficiency and the percentage voltage regulation of the system. See here, students, here we are going to study about the classification of transmission lines. Based on what the classification transmission lines are classified, the equivalent circuits of those transmission lines. So in the classification, we are getting short transmission lines, medium transmission lines and the long transmission lines. Clear, students? For short transmission line, we will calculate ABCD parameters and their percentage voltage regulation and efficiency. Along with that one, we can see percentage efficiency calculation also. And percentage voltage regulation. And in case of medium transmission lines, so we are going to see about, in case of medium transmission lines, so we will see source capacitor model, and load capacitor model, and middle capacitor model or nominal T model, and along with that we'll see nominal pi model. Nominal pi model. So these are the different models we are having in the medium transmission lines. In that our concentration should be more on the nominal pi model. Nominal pi model. Clear, students? So we are going to see the ABCD parameters of nominal pi model, and so Ferranti effect also we are going to study here. Clear, students? And coming to the long transmission line, the long transmission line analysis is somewhat difficult. Why? Because they are distributed parameters compared to that of short and medium transmission line. Its analysis is somewhat different, and it is the most important concept in the entire third chapter. Right? So we can say all these are important only. So short transmission line analysis, medium transmission analysis, and long transmission line analysis. Right? You cannot say which is more important every time. So we are getting sometimes question in short transmission line, sometimes we are getting in medium transmission line, sometimes in long transmission line. As the syllabus of long transmission line is more, so we are getting majorly in the long transmission line cases. Clear? But equal importance should be given to all the concepts. So in case of long transmission line, so we have to study about the surge impedance or the characteristic impedance and propagation of constant. So in that we are going to study about the attenuation constant and the phase shift constant also in the propagation constant of the system. Right? So all these things we are going to study for lossy system as well as for lossless system. Right? So lossy system study we have to study lossy system and lossless system also we have to study lossless system. Lossless system. So for both we are going to study there. And later on our concentration is on velocity of the travelling wave. We are having some questions on velocity of travelling wave, and also surge impedance loading. Surge impedance loading is the most important concept, right, in the long transmission lines case. So what are the different cases of surge impedance loading? So what happens when the loading increases on the transmission line, when loading reduces, what happens? So all those things we are going to see in the surge impedance loading case. So this is the biggest chapter we are having, very heavy length chapter in the entire transmission and the distribution part. Clear? So in case of chapter 2, we can at least expect one mark or one 2 mark question. Not both. So you can get one mark or one 2 mark question. And coming to in chapter 3 also, so we can expect one mark question, or one 2 mark question. Right? So in chapter 1, chapter 2, chapter 3, you can definitely expect one mark question or one 2 mark question. Clear? Right. Coming to chapter 4, students. So we are not having any questions in the last 15 years in the transient analysis and wave traveling in case of gate. But whereas in engineering services, every year we are having questions in the traveling wave phenomena also. Clear? So in this, we are going to study about a line terminated with open circuit, that is open circuit wave propagation and short circuit wave propagation are the most important concepts there. And different impedances, whenever the line is terminated with different impedances. So what happens when line is terminated with a cable? What happens when line is terminated with so one more transmission line, and any resistance, inductance, capacitance, all the possible things we will see in that one. Right? And when our line is terminated with bifurcated transmission line or forked line, so what happens we have to see here. Clear? So these are the most important concepts we are having. So in GATE we are not expecting any questions here in case of traveling wave phenomena, and whereas in engineering services we can get one question, right? So in ESE we can expect one mark, right? So one question in that one. Clear? And coming to the most important chapter of the transmission and distribution, the voltage control and the power factor correction, right? So without a question in this one, so we cannot expect a question paper. So in this, we are going to see what are the methods of voltage control, right? What are the equations related to voltage control, and from that one, what are the devices of voltage control. So these are the devices of voltage control: synchronous shunt capacitor, not synchronous shunt capacitor, shunt inductor, series capacitor, and the synchronous motor. And along with that one, we'll see some power transfer equations also. Shunt capacitor, shunt inductor, series capacitor, and the synchronous motor. Synchronous motor. So these are the devices we are having. And in the synchronous motor, we are going to study about synchronous condenser, synchronous condenser, we'll see, and also we'll see synchronous coil, and also we'll see synchronous phase modifier, synchronous phase modifier. So these are the devices we are going to see in the synchronous motor. And the power transfer equations we are going to see. So what are the advantages of knowing power transfer equations? What are the calculations we can do by using them? So the most important parts are this one in the voltage control and the power factor correction, students. Clear? Right. So we can definitely expect 1 2-mark question here. 1 2-mark question we can expect, or sometimes 1 1-mark question also we can expect. So 1 1-mark or 1 2-mark we are going to get, right? So if you are getting 2 marks here, in other chapter you are going to get 1 1-mark. But definitely they are asking a question in a voltage control process. Now coming to the next chapter, chapter 6, in 2022 we got a question in the single core cables, right? About the calculation of power loss in decibels. So here underground cables, we can expect only 1 1-mark question. Not every year, right? So sometimes they are asking, sometimes they are not asking. But up to 5th chapter, we can expect questions. So beyond that one, in 6, 7, 8, 9 chapters, so we are having less number of questions. Clear? So single core cables we have to see, and 3-core cables and dielectric losses in the cables also we have to see. These are the most important parts in case of the cables. So in the single core cables, the insulation resistance calculation is the most important, and capacitance calculations of the single core cables also somewhat important. And 3-core cables and dielectric losses in the transmission lines we are going to see. Clear, everybody? Now coming to the next chapter, the overhead line insulators. In case of the overhead line insulators, we'll see the potential distribution in the string of suspension type of insulators. And string efficiency also we are going to see. Clear? So these are the most important parts of the insulators, and we are not getting any questions in the recent years. Past 20 years, we are not having any question in the insulators in the gate. But coming to engineering services, we can definitely expect a question in the insulators, right? So it is important for engineering services. So not only this one, so this underground cables is also important for engineering services. Clear? But for gate, we can expect only 1 1-mark question here. But whereas in insulators, overhead line insulators, for the past 20 years, we don't have any question in the insulators. But it is important for engineering services. So we can get a question in the engineering services, at least 1 question. Clear? And coming to corona is a very simple chapter and very simple concept phenomena. We are going to study about that one. So what are the factors affecting corona, right? So how to eliminate corona, right? How to design conductors based on corona we are going to see, right? And in corona also we are not having a question in the past 20 years, but it is important for the engineering services, right? So in engineering services, so in objective we can expect at least 1 question. At least 1 question in the engineering services, but not in the gate students. Clear, everybody? Now Coming to the last one, distribution system. So distribution system is somewhat important chapter. So we are having some good problems in the distribution system, and we can expect at least one mark or 2 mark question in the distribution system. Students. So it's one of the most important topics or one of the most important chapters. But the calculations in the distribution system are very easy and we can learn them very easily. Clear? So this is the complete syllabus students. And so in this syllabus we have given, so what are the most important parts? So if you see here, so the most important parts of the transmission and distribution syllabus are, so you can see the first chapter, second one, third one, fifth one, and distribution. So we can give 2 stars for this one, and for cables we can give 1 star, right? So chapter 4 is not in the syllabus of GATE, right? That means not in the syllabus means they are not asking the questions in the traveling wave phenomena, and corona in overhead line insulators also they are not asking in the recent years. But we have to study them and we have to learn the concepts. Why? Because we have to prepare for the local state government exams also. Clear? This is the syllabus set, students. Now coming to see here, this is the single line diagram of the power system. In the single line diagram of power system, we are having the generators and we are having the loads. The first category between generator and the load, so can be done based on the active power, which means that an element which delivers some positive value of active power is called as a generator or a source. And an element which takes or which absorbs some positive value of active power is called as a load. So it is taking some positive value of active power and it is delivering some positive value of active power. That is the basic difference between source and the load. So it is delivering source, but transformer is not a source. Transformer and transmission lines are the power transmitting elements, right? So it absorbs some active power, it gives some active power, but whereas in this zone we are having the power losses. Clear? So the load takes both active power absorption and reactive power absorption also. So it is going to take both positive value of absorption based on the requirement. Suppose if you are having synchronous motor which is over excited, that is going to absorb negative reactive power, so that the reactive power can send back into the transmission system or to the local loads also. Clear? Based on the situation we have to discuss that one. But most possible loads are the inductive loads, so they are going to take active power and the reactive power. And the generator we can fix it for the synchronous generator which is able to deliver both active power and the reactive power. So based on the supply, we are having 2 types of generators. One is the DC generator and the other one is the AC generator. In case of AC generators, we are having 2 types again. One is the synchronous generator and the other one is the induction generator. So both types we are having. Clear? So synchronous generator is the constant speed generator, whereas induction generator is the variable speed generator, or we can call it as asynchronous generator. Based on the reactive power, we are going to see them. Clear? Now we'll see the reactive power flow, or which are the sources and the sinks of the reactive power, we will see that. Clear, students? Just check it. Sources and the sinks of the reactive power. Sources and sinks of reactive power. Please check it. We'll see the elements which are sources, which are sinks, which are sources and which are sinks. Sources of Q, and we'll see sinks of Q also. Sources of Q. Next, sinks of Q. Sinks of Q. Q means reactive power. And neither source nor sink of Q. Neither source nor sink of Q. Neither source nor sink of Q. Nor sink of Q. Clear? Right. And we'll see the various elements for that one. So we'll see the elements which are connected here. We'll see the elements. So these are the elements we are going to see. These are the elements we are going to see. See here, students. Right. See here, students. First of all, the synchronous generator. Synchronous generator. The synchronous generator, first of all, is it a source of reactive power or a sink of reactive power? The synchronous generator is a source of reactive power or sink of reactive power, right? The synchronous generator is having the excitation. So whenever it is having the excitation, right? So we can control the excitation of the synchronous generator. By controlling the excitation of synchronous generator, we can make the synchronous generator to deliver the reactive power, to absorb the reactive power, and to stay calm also. Clear? Therefore, we can say the synchronous generator is a source of reactive power, or it may be sink of reactive power, or it is neither source nor sink of reactive power also. Clear? Which means that whenever synchronous generator is overexcited, so that it is going to deliver some positive value of reactive power. Or whenever it is underexcited, it is going to absorb some positive value of reactive power. And whenever it is normally excited, it is going to absorb. It is not at all going to absorb any amount of reactive power, or it is not at all going to deliver any amount of reactive power. Clear? And coming to the next device, the induction generator, we'll see. Induction generator. In case of induction generator, students, induction generator, in case of induction generator, the induction generator is always a sink of reactive power. It is never be a source of reactive power. So that it always takes the reactive power from some other persons. Therefore, it will be a sink of reactive power. And it is not a source of reactive power. This operation is not possible. And this operation is also not possible in case of the induction generator. And coming to the transformer, right? Coming to the transformer, the next element. So the transformer is the next element, we can say. In case of transformer, the transformer is always a sink of reactive power, is always a sink of reactive power. So this operation and this operation are not possible in case of the transformer, right? And coming to the next one, coming to the next device, the transmission line. The transmission line. Transmission line. Transmission line. In case of the transmission line, please check it, students. The transmission line, based on the loading, it may deliver active power, or it may deliver reactive power, or it may absorb reactive power, and it can stay calm also. That means based on the situation or based on the loading on the line, so the transmission line is going to deliver reactive power, or it may absorb reactive power also. So this operation is possible. It may be a source of reactive power, or it may be a sink of reactive power, and it can stay calm also. It can stay calm also. Please check here, students. So it is going to be a source of reactive power whenever the loading on the line is less than surge impedance loading. Whenever the loading on the line is less than surge impedance loading. And it may be a sink of reactive power whenever the loading on the line is more than that of the surge impedance loading. And it is neither source nor sink of reactive power, then it will be whenever loading is exactly is equivalent to surge impedance loading. So all these operations are possible. All these operations are possible in case of transmission line. And the next element we can see the synchronous generator, synchronous motor. In case of the synchronous motor, I am writing SM. So SM means the synchronous motor. Synchronous motor, whenever it is over-excited, synchronous mission, the same operation we can get. The same operation we can get in case of synchronous motor also. It may be a source of reactive power whenever it is over-excited. Source of reactive power whenever it is over-excited. And it may be a sink of reactive power whenever it is under-excited. And whenever it is normally excited, it may be source of reactive power or the sink of reactive power. Clear? And coming to the induction motor, the last and the most possible load. And the most possible load, we can see the induction motor. So if you see the induction motor, students, in case of the induction motor, so the induction motor is never be a source of reactive power. It is never be a source of reactive power. It is always a sink of reactive power, right? So this operation is not possible, and this operation will be possible, and this operation is also not possible in case of the induction motor. So based on this, we can select the best sources and the best loads. Now tell me, which is the best source, students? Which is the best source? Which element we can pick as the best source? The best source is the synchronous generator. So where all operations are possible. All operations are possible. That means it is going to deliver both active power and the reactive power. Clear? So with respect to reactive power and with respect to speed, right? So we can say the synchronous generator is the best generator, we can say. And coming to the best motors. So if you see, synchronous motor is looking as the best motor, but synchronous motor always rotates at the constant speed, but whereas the induction motor rotates at variable speed. And also induction motors are self-starting, right? And the construction of induction motors are very simple, and whereas synchronous motors are not self-starting, and it is not possible to construct these motors very simply. So induction motors are very economical compared to that of the synchronous motor. And so based on the applications and based on the starting properties and based on the construction point of view, we can say induction motor as the best motor. So even though even though it is unable to supply any amount of reactive power. But based on the construction point of view, analysis point of view, and application point of view, we can say, so that is the best motor, we can say. Clear, students? So this is what the introduction part we are having here in this class. And coming to the preparation strategy, so we have given the entire syllabus, weightage syllabus here, and most important concepts, and we are getting approximately 3 to 4 marks, sometimes 6 marks also we got in case of transmission and distribution. And please go through those topics and try to prepare them, right? Thank you.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Life's main classes, Postal Study course, Test Series and Interview Guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in Test Series, I have given various mock tests which have helped me in the time of real exam. And in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi. And I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.